Hi students, in this session we are going to discuss clearly a more frequently asked question, why phenol is more acidic than alcohol. So let us see, this is a phenol and this is an alcohol. See phenol, this alcohol where R represents a alkyl group. Let us consider this as a methyl group. Okay, so this is an alcohol. Now two reasons has been given, right, why this phenol is more acidic than alcohol. First one is due to the presence of polar OH group. The OH group present in this phenol is more polar in nature, and also due to the resonance stabilization of this phenoxide ion. Okay, so we are going to see these 2 points in detail. So before that, the OH group which is present in phenol is considered to be more polar when we are taking about this OH group which is present in the alcoholic group. See, actually the acidity depends upon the polar nature. If the OH group is more polar, then acidity is more. If it is less polar, then the acidity is less. Actually, the OH group which is present in this phenol is directly attached to a sp2 hybridized atom. This is sp2. What do you mean by sp2? See, if a carbon atom is having a double bond, then we call that carbon atom as sp2 hybridized carbon atom. See here in this phenyl ring, we are having 6 sp2 hybridized carbon atoms. Okay, see this carbon is having double bond, this is having double bond, and obviously this is also having a double bond, this is having double bond, this is, and so 6 sp2 hybridized carbon atoms are there. Since it is having 6 sp2 hybridized carbon atoms, this is a strong electron withdrawing group. Since the OH group present here in phenol is directly attached to this phenyl ring which is having 6 sp2 hybridized atom, it is a strong electron withdrawing group. So thus this phenyl ring will be pulling the electrons from the oxygen atom present in this OH group. So since it is pulling the electrons, this oxygen will be getting a partial positive charge. Understood, students? Let us consider the phenol here. See, let us consider the phenol ring. This is OH. Okay, this is phenol. The this oxygen is already electronegative in nature. What happens? The electrons present in this oxygen will be pulled by this phenyl ring, so that the electrons will be moving towards this phenyl ring. Okay, that's what we are going to see what happens during the movement of electrons. The electrons present in this oxygen, it shifts towards this bond, so that in order to compensate, the electrons from here shifts to this position, so that since the electrons are shifting here, this oxygen will be obtaining a partial positive charge, and here we'll have a double bond, and now this electrons are shifting to this position. Here we'll be having the negative charge. Next, see the next structure. See here the electrons will be now shifting towards the next bond. Okay, now in order to compensate, here it shifts to the next position, so that the electrons will be concentrating on this position, so that we are getting a negative charge here. So check the bond now. Since it is transferring here, we are having a double bond here, and also a double bond here. Now what happens to the next structure? See, there is delocalization of electrons. The electrons are delocalized to this position. In order to compensate, again it shifts to this position. Likewise, shifting of this electrons will be taking place, that is delocalization of electrons. The electrons will not be localized in a particular position, rather it will be delocalized. Because of this delocalization, we will be having different resonating structures. Okay, due to the resonance, because of this resonance, the polarity of this OH bond increases. Okay, already the oxygen atom of this phenol is highly electronegative, but now the oxygen has got a positive charge, so it will be attracting more and more electrons from the hydrogen. So hydrogen can easily go out. So since electrons are attracted towards oxygen, the hydrogen can easily go out, and since it is more polar, this ionization takes place. What is ionization? The hydrogen is going out, so that this is a phenoxide ion is formed now. So now this phenoxide ion is more stable due to the resonance stabilization. Okay, so just like phenol, this phenoxide ion will also be undergoing resonance. There will be shifting of electrons. Understood, students? See, the negative charge is getting shifted to this bond. In order to compensate, again the electrons are shifted to this. So again there will be delocalization of electrons, just like that of phenol. In phenoxide also there will be delocalization of electrons. So again, since the electrons are shifted to this place, here we are having a negative charge, and again in order to compensate this negative charge will be shifting here. Again here the atoms, electrons will be shifted to this position. Likewise there will be delocalization of electrons and will be having different resonating structures. So finally this is similar to this one. This is the resonating hybrid. Okay, since different types of resonating structures are formed, since the electrons are delocalized completely, this phenoxide ion is more stable. So this phenol is more stable, more acidic, because of the more stability of this phenoxide ion. Both phenol and phenoxide ions on resonance stabilized. This phenoxide ion acquires greater stability because it carries only negative charge, whereas but when you are taking into account alcohols, see this alcohol will have an example. This is CH3R represents an alkyl group. Let us take CH3. Okay, now this is an alcohol. So after the removal of hydrogen, after the removal of this hydrogen atoms, that is, this forms, alcohol forms an alkoxide ion. This is alkoxide ion. Alkoxide. Okay, alkoxide ion. See this. See, in the case of alcohol, the alkoxide ion, which is formed due to the release of proton from the alcohol, is not resonance stabilized, just like that of phenoxide ion. And one more thing, the alkyl group which is attached to the alcohol is not electron withdrawing, rather it is electron donating. So the alkyl group, CH3 group or whatever may be the alkyl groups are electron donating groups. So it will be donating electrons. Okay, this will be donating electrons, right? So this alkyl groups will be donating electrons. So unlike that of phenoxide ion, phenyl ring, this alkyl groups, they are electron donating, so that it will not be helping the release of hydrogen easily, removal of hydrogen. Okay, the alkoxide ion is not resonance stabilized. So these are the reasons why alcohols are much less acidic as compared to phenols. Fine students, I hope you might have understood the reason why alcohols are less acidic than phenols. We shall meet in the next session with one more important topic. Until then, it's Anita Raj signing off from you. Thanks for watching.